Okay, hello. So this episode we're going to talk about surface area. Surface area is a natural extension, actually, of arc length, because if you think about it, if you have a curve and you trace out the arc length, and then if you revolve that around, you get surface area. So let's go to writing mode and look at that. Oops. Okay, why am I having a hard time doing this? There we go. Okay. Oh, wrong color. Okay, so if you have your curve f of x and you're going to be going from a to b, we now know how to calculate the arc length. The arc length is the integral from a to b, square root 1 plus f prime squared dx. Now, if you want to rotate that around, like let's choose some point right here, xi, and if you rotate that around, you get a length, which is going to be 2 pi times the radius. So it becomes sort of natural to realize that the surface area is going to have a very similar formula to the arc length. The surface area is going to be the integral from a to b 2 pi f of x times the formula we had from arc length of square root of 1 plus f prime squared. And so you might recognize the 2 pi f of x. That's this circumference that you would basically get right here as you integrate it around. And then you sort of like add on the fact. So instead of multiplying by delta x, which we would normally do, instead you have that arc length, which was the delta x 1 plus delta y over delta x squared, which is why you have to multiply by this, because the shape curves a little. So instead of just having dx, you have to multiply by the square root of 1 plus f prime squared, which gives you, it takes into account the curviness. So let's do an example of this. Let's calculate the surface area of f of x equals square root x on the interval 1, 4. So if we look at the shape, our square root x looks something like that. We're going from 1, 2, 3, 4. So you can imagine if you revolve that around, you get this sort of cone sort of shape, and you want the surface area that you get. So let's set this up. We're going to integrate from 1 to 4, 2 pi f of x. So remember your f of x equals square root x, which is x to the 1/2. And then you're going to have times the square root of 1 plus f prime squared. Well, the derivative of this is going to be 1/2 x to the minus 1/2. So f prime quantity squared is going to be 1/2 x to the minus 1/2 squared, which will be 1/4, 1 over 4x. So you get 1 plus 1 over 4x dx. Let's distribute in that square root. So when you do square root x times 1 plus 1 over 4x, you get the square root of x plus, and then when you multiply that x in, they'll cancel, so x plus 1/4. So you get the integral from 1 to 4, 2 pi square root x plus 1/4 dx, which we can then solve with a u substitution. We'll let u be equal to x plus 1/4. Our du dx will be 1, which means our du equals dx. Okay, so we can make our changes. We can factor out the 2 pi. Square root x plus 1/4 becomes root u. The dx becomes du. Okay, when you change the bounds, you'll get 1 plus 1/4, which is 5/4, 4 plus 1/4, which will be, I think, 17/4. Okay, now when you take the antiderivative of this, the antiderivative of u to the 1/4 is, u to the 1/2. 1/2 plus 1 is 3/2. So 2/3 u to the 3/2. So we'll get 2 pi 2/3 17/4 to the 3/2 minus 2/3 5/4 to the 3/2. And if you go and calculate that and plug everything in, you're going to get pi over 6 times 17 root 17 minus 5 root 5, which is approximately equal to 30.86. You can have Wolfram actually calculate that for you, and you get this number, which gives you the surface area. So this is in units squared because it's surface area. Okay, thank you.